But Shiny was the way that paved the way for an R user to get into this space without having to become an HTML, CSS, or JavaScript expert to make all that happen. You have all the tools available to go to that production state without having to change your whole dev stack to do it. You can stick with Shiny to do it. Shiny is kind of lazy by design. It's only going to rerun things unless it absolutely has to. And so Shiny is coming into a space where there are solutions, however, they tackle it in a different way. But now with Shiny for Python, we could have one stack to do it all, but yet not compromise the benefits of what Shiny brings by moving to one of the other frameworks. And I've had users that have been amazed that we can build something like this with code without having to pay a vendor thousands or perhaps even millions of dollars to build a custom proprietary package to do it. But I see Shiny playing a huge role in the way that we really interpret these results and the way that we can link results together.
This is where we bridge the gap between innovation and scientific discovery. This is where technology meets science, a podcast by Epsilon. Each episode brings you insights from industry leaders who are pushing the boundaries of what's possible in life sciences. Enjoy, and if you like the series, click that subscribe button. This series is brought to you by Epsilon, a technology company that empowers pharmaceutical and life science companies to leverage open source technology for faster, data-driven decision-making in regulated environments. Welcome to another episode of Where Technology Meets Science. Our guest is statistician, developer, podcaster at Eli Lilly. He's a director at Statistical Innovation Center Capabilities, responsible for design and analysis of clinical trials for immune disorders. With a strong background in biostatistics, clinical trials, machine learning, statistical computing, computer programming, he performs statistical analysis of specialized biomarkers using R and computing infrastructures. Open source advocate and creator, producer, and a host of the first and the biggest podcast for R enthusiasts since 2012. And today you are in the role of a guest, not a host. Eric Nantz, welcome. It's great to have you here.
It's a pleasure to be here, Nat. Thank you so much for having me.
Thank you. Today we're going to talk about Shiny evolution. Shiny started as a prototypic framework for building analytical applications in R in 2012. And fast forward in 2022, Shiny for Python came out. Before Shiny, it was a big challenge to build applications and integrate statistical computing and analysis with user-friendly graphical user interface. And Shiny was a game changer. So Eric, if you could just maybe briefly introduce what were the beginnings of Shiny and what was the main promise? Because I'm pretty sure you remember exactly how it started.
Absolutely. It's a fascinating history of how Shiny came to be. And I've had the pleasure of talking to the author himself about this many years ago, Joe Chang, who is the CTO at Posit. But it actually dates back to the RStudio IDE itself, when RStudio, at the time they were called RStudio, have released the IDE, and it was, embraced very highly by the R community. And in particular, there was a professor at Macalester College, Danny Kaplan, who had been using that to help his students learn R and teach statistical concepts. And he was so enamored by it that he was hoping that RStudio itself could give a way to bring these kind of interactive controls to, say, statistical outputs, visualizations, to help with his teaching. And so Joe Chang and JJ Allaire, the president of, or I should say the founder of RStudio, took this advice and they started building in small little widgets inside RStudio itself to accomplish some of this. But as Joe has mentioned in one of my previous interviews of him, there's always more. There's always more that people want. And so fast forward to 2012, as he's ruminating through this idea, it suddenly hits him that there is a way forward to kind of have this interactive capability, but something that the R users could embrace. And that was based on the Meteor reactive framework in JavaScript. And it seemed like magic to him that it wasn't using these traditional methods such as event callers, event handling to pull off this dynamic updating of a user interface. So basically, he had an epiphany and wanted to use our conferences of what became Shiny, a way to define the UI with placeholders for like the inputs that would be tied to a reactive like output. And he quickly strung up a prototype, shared it with JJ, shared it with others, and then lo and behold, the Shiny package was released. And it was, as you said, this was a foundational change for us in the R community, who up to that point never really had what I would consider a intuitive way to bridge the power of R for statistical analysis and the user experience of a web-based application front end. There have been attempts at it, but Shiny was the way that paved the way for an R user to get into this space without having to become an HTML, CSS, or JavaScript expert to make all that happen. So yeah, I would say my life was most certainly changed after Shiny was released to CRAN.
Okay, so what are the key benefits of Shiny and what you can actually build with?
Yeah, I remember when I first started with it, I kept it pretty basic, stuck with the hello world type of examples, but quickly realized, you know what, Eric, all those visualization packages you've used in the past, or all those algorithms, those modeling packages you've used, this is all just R code, right? So I can take a lot of what I've already built, but then put these friendly widgets that, again, I don't have to use HTML code for to build that into a user interface function, these intuitive sliders, these drop downs, these other components, and then to be able to tie in to an automatic update of the output itself. And it was amazing that it was pretty quick when it was being changed in the UI. It was absolutely amazing to me, all based on reactivity. But one of the key benefits as well is that Shiny is kind of lazy by design. It's only going to rerun things unless it absolutely has to. And that was a big shift to what I've done in the past, where if I change one thing in my R script or whatnot, one input, I have to run the whole thing down to get the rest of the outputs refreshed. In Shiny, it was only doing what it needed to do. Admittedly, it took a bit to grasp that in terms of like real intricate reactivity, but I was able to have a pretty high performing app pretty quickly just based on the foundations that Shiny set in place. So at that time that I started with Shiny, I only knew enough HTML to know basic ways of doing like lists or bullet points in an HTML page. I did not have any prior web dev experience. So I felt like it was a game changer for me that I could get into this space and gradually build up my expertise in web development, but I didn't need it to get started. I think that is a huge benefit. And the best part is that once you go through that prototyping stage, especially in the community now, you have all the tools available to go to that production state without having to change your whole dev stack to do it. You can stick with Shiny to do it.
And then you mentioned the community. So what is the actual impact of the open source community to develop and build the framework? Because this is not something, this is not corporate standing behind it. There's just people wanting to change, bring the tools that are going to make our work easier.
And this is, again, going to the strengths of R itself, its foundational pillars being built on open source and the community of R packages. Shiny was an excellent fit for this. So as others, I was an early adopter. There were many others as well. And we would share notes on, at that time, the Google mailing list that the Shiny team maintained of different ways we were using Shiny. And we're all learning from each other. And more importantly than that, the Shiny team themselves were learning from us about how we were using it. And I think that direct feedback, that direct relationship that was being established in an open dialogue that, a newcomer like me could learn from already experts in that area to learn what they were doing, And it really, I would say, crystallized when Posit, or our studio at the time,
Mm-hmm.
held the first ever Shiny conference back in Stanford many years ago. That's when a group of 80 or 90 of us got in the room, listened to Joe Chang and others from the team, really instilled the principles that he wished he could tell us himself, but this was his first opportunity to do it around reactivity, around best practices. And ever since then, I think I saw an explosion of additional tooling that the community has built around Shiny itself, but also another great component that I think is taken off is the ecosystem of HTML widgets that really play nicely with Shiny too, and not just for, say, an interactive R Markdown document or a Quartal document. You can use these widgets in Shiny, and that already opened up a whole bunch of possibilities for the community to really contribute these interactive type of building blocks that Shiny is very well suited for. So I think without the community, Shiny is not where it is today. And it's been great to see just the rapid adoption of the tooling around this space for sure.
And then, do you see any big barriers to widespread adoption of Shiny, or maybe some barriers in general, like obstacles that you see right now, or problems that you wish they were solved within it, so it would be easier to use it?
It's an excellent question because I've been, admittedly, you might call me biased. I am very much a fan of what Shiny can bring to the table for my daily work, but also seeing what it does for others in the community that have been a part of this since the beginning. A lot of the barriers I see are actually more about the adoption of R itself in various groups, whether they're software development groups or IT groups. It's a lack of familiarity about the language itself. And admittedly, a lot of people will tell you R is a language of quirks, a lot of different things it does that may not be the standard way another language like Python or JavaScript or other frameworks handle various concepts. But it's interesting that R was uniquely positioned as, a great starting point for Shiny itself with those aforementioned quirks in the language like non-standard evaluation, positional arguments, and the like. I think for groups to adopt Shiny, it's really more about, in my opinion, the adoption of R itself. And I will say that the industry is coming along quite nicely. I should say different industries for sure. But I would say even some recent conversations I had in other groups I'm a part of, they have trouble administering R developers that may be still coming from that data science type of workflow and not so much from the engineering workflow. And there are some people that get jaded about that. They have difficulty managing dependencies. And then meanwhile, developers in Python are largely building software engineering type of applications or deliverables. And they have just because of the adoption of Python itself, probably more resources to draw upon. Whereas for R, you still kind of have to know where to look. But I've been an advocate of trying to change that and giving people resources to look, especially from this community adoption and production state of Shiny. I think there are now a lot more resources than there were in the beginning of Shiny because all of us are just learning together about the best ways to use it in production. But I think we're well on the path forward there.
And also right now we have Shiny for Python, which the introduction of Shiny for Python was a strong indication that Posit has to catch up with bringing tools also to the Python community. So what new opportunities does it bring in general to the data science analysis, but also to clinical data analysis?
It's been really fascinating to see where Shiny for Python has gone, especially since, like you said, its introduction just a few years ago. I still remember being in the keynote by Joe Chang at the 2022 Posit conference where it was announced, and we kind of got the hint along the way that something was coming on that. I think it opens up a lot of doors for those that want to share just the benefits of creating a user experience with the reactive paradigm that Shiny brings that admittedly, unlike in R, where I told you earlier that there really wasn't anything like Shiny before it was introduced to the R community. There were attempts at various things, but nothing at the level that Shiny was doing. Whereas when Shiny for Python came to be, there already are more than a couple of established frameworks for building web-based experiences like Streamlit and like Dash. And so Shiny is coming into a space where there are solutions. However, they tackle it in a different way. You might say for Streamlit, it is more for turning that analytical script in Python to a web application with very minimal effort. But with that, does it really scale as well as Shiny does? In my humble opinion, I don't think it does. Then you have Dash that kind of takes more of a different approach where it's really all about the efficient deployment at the cost of some complexity to make all that happen. I think Shiny is right in the middle there. And with that comes the benefit of, if you're a Python user, I think the syntax of Shiny for Python should be relatively straightforward to adopt, but it opens up a lot of doors, I think, to those that want to bridge novel analytical techniques that may be in Python, they may be in other languages, but Shiny for Python will give those teams that already have that Python-based stack a way to get this, from prototype to production framework without switching frameworks in that evolution. I think they can stick with Shiny for Python to really get their job done effectively. And I can tell you that from other experiences at my day job, there were teams that really wanted to use Shiny for the product we were doing, but then everything else in that, you might say, app stack that we were building upon was still Python based, whether it's machine learning, whether it's some other analytical, packages. But now with Shiny for Python, we could have one stack to do it all, but yet not compromise the benefits of what Shiny brings by moving to one of the other frameworks. So I think it opens up a lot of possibilities across the different spectrums of industry. And in life sciences, I think the adoption is still growing for Shiny for Python, but I think the seeds are there to take it to another level as the teams adopt it.
And then what does it mean for R?
It's an interesting point because I still stand by what I said, that I think Shiny for R is always going to feel, to me personally, the more native experience. And again, that's a very biased opinion because I've been using R for over 20 years. So it's my comfort zone. It's what I know well. It's the fact that we have so much in the ecosystem that I can draw upon to take the Shiny experience to the levels that I need to take. I do think, however, I think there could be learnings that, say, the Shiny team gets as they push Shiny for Python out to more industries or more groups, more adoption in that community that could reciprocate, that could benefit the Shiny for R experience. And we're starting to see that a little bit in Shiny for R, we've got the excellent BSlib package that is helping us bring more streamlined user interface experiences based on the Posit team and the Shiny team, looking at what the community has been building with, say, dashboards and other interfaces, and trying to make that a first-class, citizen or first-class framework for others to use on the R side of things. And they're actually putting that functionality in the Shiny for Python proper. They're kind of learning from what the R side did to make the Python experience as smooth as possible. So I see that going both ways. I wouldn't be surprised if, with the adoption of Shiny for Python, we see more improvements on the R side of things, just based on what the users are doing there. So true, it'll to be determined how quick that goes, but I am optimistic we'll see improvements even with that adoption too.
So you are biased, but if you could just say how do they compare to each other?
They're largely similar syntax, and I admittedly am not a Python expert. I know enough to be dangerous, as they would say. I don't feel like I have to launch into a whole bunch of tutorials to get a Shiny for Python app going quickly because I come in from the experience of building user inputs, building reactive objects, building outputs that bind to those inputs. From the R side of things, the syntax really is quite similar. And that's a credit to the Posit team for making that happen and not making me totally switch my development, cognitive mindset to build that application. So I do think that transitioning from one to the other isn't as costly of a technical exercise as it might be if you go from one language to another in a different framework. So I am optimistic that people could pick it up relatively quickly.
Okay, and let's just talk about clinical trials and the impact of like Shiny adoption within clinical trials. Could you maybe give us a couple of examples of packages that are extremely helpful in clinical data analysis? Maybe some data visualizations. What's out there and how these help?
There is so much to choose from, and for those of us in the life sciences field, when we were getting started with Shiny, we did keep things pretty basic for the most part. But the things that were in my toolbox right away were some of these packages that also have this other relationship with the HTML widget ecosystem, such as DT, authored by Ihuesia, and now more recently, the reactable package. Those are hugely important when you want to look at the data, drill down on various records, but have these nice bells and whistles to enhance that user experience, such as having like nested rows that you can expand and collapse, custom client-side filtering, freezing panes. You could even have an Excel-like experience in Shiny if you wanted to with additional packages. So there's lots of ways to really have that optimal viewing experience of data itself, which have been very, very important for the applications I build. And then when we get to the visualization side of things, I have been a massive fan of John Kuhn's eCharts for R. It is such an elegant interface, and so quickly can I have, say, a line chart that's totally interactive, has bindings to Shiny itself, so I can tap into what inputs are being tweaked, what's happening on the reactive side of things, and have this highly interactive plot that the users are able to zoom in quickly, able to do, cross-talk like functionality, or clicking on a line or a point could bring up additional insights that are really fleshing out that particular selection. To be able to build all that together via crosstalk or other packages, that's been huge for me. And I've had users that have been amazed that we can build something like this with code without having to pay a vendor thousands or perhaps even millions of dollars to build a custom proprietary package to do it. You just have to know where to look, right? And then try it out, see if it works, get good user feedback, and build these interactive displays of data and visualization. And then on top of that, to be able to leverage APIs to tap into, say, databases, or on Amazon Web Services or other object storage mechanisms. That's been great to really take advantage of new cloud resources into Shiny applications. And I'm working on that as I speak, actually. It's a fascinating area to tap into.
So you mentioned it's definitely like way cheaper than using proprietary tools. So why there's still so many companies being reluctant to move to Shiny, to R, and then open source tools, especially within the clinical trials, the pharmaceutical industry?
There's a lot to unpack there. I will give you my takeaways of it is that it really depends on the comfort level of those that are actually building these interfaces and what they're accustomed to doing. I come from a very code first mindset. I feel like writing software with code gives you the best chance for reproducibility, the best chance for extension, the best chance for collaboration, especially in the world of open source. As we talked about, Shiny itself being open source, it is never where it is today without that happening. I think everybody would agree on that. You do have, a handful of developers out there, statisticians, data scientists, who really do not like that mindset when it comes to building user experiences. Can they write code to do a data analysis? Yeah, great, sure. But then they want that more WYSIWYG kind of design with components that they can drag and drop, choose, and whatnot. And that's why I think you'll always see that, at least present in this community especially. The part I always challenge about is that when you want to do something outside of its confines, when you want to do some extension, say you want to tap that resource that you're building and say Power BI or Tableau or whatnot to a high performance computing grid cluster on-prem or an on-demand cloud-based bursting mechanism. I hate to say it, but good luck, because With Shiny for R, I can make all those connections happen. I can go end to end with getting data from a database, preparing for a machine learning algorithm or an HPC type of analysis, tapping into that said resource, and bringing it all back with an interactive visualization with the over 100 plus HTML widgets that I have at my disposal to really surface those insights effectively. I challenge anybody to try to find that with a proprietary off-the-shelf software, the ability to do all of that in one framework, whether it's Shiny for R or Shiny for Python, and being able to extend it for the future. I've had apps that I've had in production for 7 years running because I was able to make that connection, and we never once have thought about, do we need to switch from Shiny? No, Shiny's here to stay, and we just keep building on top of it with a solid foundation.
What stops those companies from moving? There are like obviously so many different advantages and so many benefits of using open source over proprietary tools. So why does it? Is it security? Is it like change management? What stops those companies?
A lot of it, I think, is on the change management, cultural side, where a lot of developers, statisticians, data scientists, especially in life sciences, when they find something that works well enough for them, even if other people are saying, hey, in this ecosystem, you might get such and such benefit, there is a bit of resistance to change. If it ain't broke, don't fix it, as the cliche goes. So, but I do see, I am an advocate of R in life sciences. I'm part of various working groups to help that adoption. We are seeing that tide turn slowly but surely. It just does take a lot of change management, cultural shift, and frankly, buy-in from leadership to really invest in that changeover, but also making it easier for their teams to make that switch. It can be daunting to go from a proprietary type of experience and building these applications to a code-first approach. The key is getting them set up on the right foot, automating as much as you can in the setup so that they can really concentrate on learning that new paradigm without feeling like they're just wasting their effort in doing so. I think we're making strides, but I think there is a ways to go.
Slowly but surely. What are the potential paths for Shiny evolution? What do you see adoption in maybe different verticals, different industries, or how it will develop within the pharmaceutical and life sciences?
Yeah, I feel very fortunate that I think, especially as we're talking in 2025, that the presence and benefits of Shiny are now becoming pretty well understood in life sciences. And it's really a matter of where can we take what we've been building in terms of like internal type of applications that our companies are using for, say, decision making, for automation, and really seeing those similar benefits across a whole spectrum of a clinical analysis. I think we're on the right path. And for those that aren't aware, I am part of a submissions working group under the R Consortium, and we are piloting the use of Shiny in submissions. And I'm happy to say that we've had success already in those pilots, and we're pushing the envelope even further in the recent years to make this even easier for the reviewers to use to analyze and digest what could be a more voluminous type of set of clinical results that a typical submission might have. We're going from looking at static displays of like rich text file formats or PDF formats to an interactive application where you can really drill down on those results as you see fit and really see how things link together. That's the next frontier to me, is making this review experience as seamless as possible and taking advantage of interactive frameworks like HTML that Shiny bring to the table to make that review experience really optimal. And I think we're just scratching the surface there. There's more to come in this space, but I see Shiny playing a huge role in the way that we really interpret these results and the way that we can link results together in an efficient manner.
And I'm also happy to say that Epsilon has played an important role in bringing those pilots to life. Okay, are there any alternatives that would threaten Shiny?
It's an interesting thing that I've pondered about. I mentioned in the Python ecosystem, you've got the established frameworks like Streamlit and Dash, and they're going to have their user base, and sometimes that can be tough to convince to adopt to a new paradigm for building these web experiences. And certainly on the R side of things, I'm not really seeing a major, alternative framework. I've seen a couple thrown in and out, but the mind share that Shiny has, I don't see that going away anytime soon. I think the bigger potential, things that could threaten Shiny are really more about in software development, in IT groups, the cultural, say perception that, oh, that's great, but hey, you know how we do things in production. We do these more complex React or JavaScript based frameworks to do these experiences, and it works for us, and we're not changing. I think that's the bigger issue to solve, and I think we are on the way thanks to great resources in the community. I've certainly done my best to advocate for those resources with the Shiny Developer Series of showcasing a lot of those tools to help bridge out those gaps that people might see when they try to make Shiny more prevalent in their organizations. I think that cultural shift is probably the biggest barrier I see. I will say, though, one technical achievement that I think is a huge feather in the cap of adoption in Shiny is the use of WebAssembly. That opens up so many possibilities for how we can share these applications, especially in the field of education or training of these statistical concepts for people to get quickly access to these applications that, again, I don't have to be a JavaScript expert to build this with. There are now frameworks, thanks to George Staga's efforts with WebR and WebAssembly, that now I can take a Shiny for R app, convert it to WebAssembly of a couple lines of code, and lo and behold, even share that with regulators. I think this is a fascinating field that I'm keeping a close eye on, because I think this could increase the adoption tenfold on both the Python and the R side of Shiny.
It's very exciting news. We could probably go, and I know we could go probably forever talking about Shiny, but we're going to be slowly wrapping up. And I've got one last question for we ask all of our guests. What is the problem in your field? You can think very broadly. The problem that you are surprised that hasn't been solved yet.
How much time do we have? No, I'm kidding. There's a lot of areas that I'm very passionate about seeing more robust solutions for. So it's not necessarily things that haven't been tackled yet in bits and pieces, but there is in the world of, software development, especially, I feel like I've had multiple hats I wear. I'm a statistician by trade, but yeah, I'm building these experiences with Shiny from a software engineering, research software engineering mindset. So a lot of times, those perspectives can sometimes butt heads, if you will, about like what is important for which perspective. But going on my engineering hat for a second, the ability to give teams a way to have a unified development stack, if you will, so that we can, as a team of developers, be able to draw from the same source of truth of that particular project's dependencies from a software perspective. And then to be able to seamlessly lift that and hopefully not change it very much when we deploy that to production. Now, so those that may be listening wondering, Eric, why are you saying this? We've solved this already. Yes, there are bits and pieces that have been solved, such as with the RM package for R to manage package dependencies. And then to deploy to production, I'm a huge fan of the container ecosystem with Docker and Podman and the like, that we can bundle a software product into a more unified, distributable type of product that with a container runtime, somebody can execute on their computer without having to know the code that was built for it. I think there's a way to have your cake and eat it too. And one area that I think is kind of growing in the world of data science and engineering that I'm hoping to give more my thoughts about in subsequent conferences and resources is this idea of using a framework called Nix to manage package dependencies at a software level, but in a way that we might be able to scale that to all parts of data science, all parts of Shiny application development, and to be able to share that effectively with others. It's still, Nix itself is not new. It's been around for over 20 years. but we're starting to see adoption in the data science field of using this as a way to unify dependency management, but across the full spectrum and not just within a particular software package. It's still early days, right? But I think we can get to that frictionless way of having these development environments that can transition to the way the production environment is bootstrapping these dependencies. There's more to come, but I'm eager to see where that takes us.
Okay. Thank you so much, Eric. It was really great to have you. If you feel like there is somebody that would enjoy this episode, please share them with them. Thank you so much. And thank you for listening.
It's a pleasure to be here. Thank you so much for having me.
Thank you.
Thank you for listening. This was Where Technology Meets Science by Epsilon. If you know someone who might enjoy this episode, share it with them and subscribe to never miss a new episode. At Epsilon, we empower pharmaceutical and life science companies to leverage open source technology for faster data-driven decision-making in regulated environments. Until the next time.